Hello everybody, thank you for joining. We'll wait a minute more for everyone to join. All right. Hello everybody and thank you for joining. My name is Philippe Ozil. I'm the Principal Developer Evangelist at Salesforce. And today I'm going to be talking to you about continuous integration and most importantly about GitHub Actions. So for today's agenda, we're going to be starting with a few things. And before I jump into the presentation, I need to give you the forward-looking statement. As always, we are a publicly traded company, so please make your purchasing decisions based on what is commercially available in the product. Again, I'm not so much going to talk about the product as in my previous sessions. I'm more going to talk about GitHub, so that should be another problem. So today's agenda is pretty simple. I'm going to talk a lot about GitHub Actions, and then I'll talk about CI with Actions, and this is most importantly in the context of Salesforce DX projects. And if we have time, I may also add a few things regarding other types of projects. Right. So let's start. So before I go down in the details of the different types of tools that we use and the different concepts, I want to give you the high-level view. And the way GitHub Actions work is by chaining a couple of different things. First of all, you have to understand that everything happens in the context of a repository. So GitHub Actions are working for a single repository at any given time. Now, it all starts with an event within the repository. So there are multiple events, I'll get back to that later on, but imagine, for example, a new pull request. This particular event triggers a workflow. So the workflow is configured to listen for a particular event type, and this workflow will execute some jobs, and these jobs will execute some steps or actions, and the orange part on this slide represents GitHub Actions. So GitHub Actions has several meanings. It can be the whole technology that is represented on this slide, but it's also the low-level artifact at the most granular level, steps basically. So let's now take a look at all of these different types of artifacts, starting from the lowest levels, starting from actions or steps. Basically, this is a single unit of work, and what this means is it can be something like sending out a command, like writing a comment on the GitHub message flow. It can be also modifying source code or running a test. It can be starting a VM, things like that. And in the context of Salesforce DX, it can be creating a scratch org or pushing some code in there. The idea is that this is just a single thing that is a unit, and it expects some inputs and outputs something that the next action can also leverage. There are multiple languages that are supported to write actions. These can be written in JavaScript, TypeScript, Python, Java, or even simple shell script, which is very convenient. And all of that runs in a Docker image of a Linux system. That's for the technical part. Now, I don't expect most of you to write their own GitHub Actions, but it's always interesting to know what happens behind the scene. And talking about them, you can actually leverage a lot of these actions without having to create your own. There is a marketplace on GitHub that has hundreds, if not thousands, of different actions that you can leverage. And you can also, most interestingly, link to a repository to directly load an action from a repository. So if you want to try your own custom action, it's very simple. You don't even need to share it with the rest of the community. You can just have your own repository and link to that repository to trigger a new action. So again, an action or a step, which is the same thing in this context, is part of a bigger entity, which is called a job. A job has multiple steps. So what is a job? Well, a job is an ordered set of steps, with some of them that are optional. So the basics is that your job will execute steps one after the other, and if at some point there's a failure, the job terminates. And some of these steps will normally be skipped, but some can be marked as always executed. That's basically the way it works. Now, the job is works also as a unit in the sense that it is working in isolated container. So all the actions that run in the job can communicate with each other, but one job cannot communicate with another job. So that's really important. This is a specific Docker image that runs the job, so it's really a unit. Now, a job is also part of a larger entity, which is called a workflow. Workflow is a top-level artifact for GitHub Actions, and it contains a set of ordered jobs. Now, these different jobs will execute also one after each other, and then they can have dependencies. So, for example, job number 2 may require job number 1, or it may not. Some jobs are allowed to fail, and the others will continue to execute. How is that configured? Well, it's all happening in a YAML file, .yml, that is located in the same directory for all repositories. It's .github/workflow, and I'll give you a little tour of one of the examples of such a configuration in a few more minutes. So it's in there. There can be more than one workflow, but these workflows are separated. They don't communicate with each other again. And in the end, after a workflow has run, there can be only a pass or fail status. And this is something that is reported in the GitHub user interface. And there are multiple places when you can see the status of a job, and also get back to that later. You can also cancel a job which is running. That's also another state that exists. Now, back to the real beginning of the story, what triggers the workflow is a GitHub event. And there are multiple types of events that can happen, but you can also filter on the sub-properties of those events. And let me get to that now. So these events happen based on GitHub activities, things you're actually doing or your users are doing, or even things that are automated that are happening on GitHub. For example, these can be pull requests, issues being opened, or branches being pushed, and the deployment of your source code, for example. Now, given those different types of activities, there's another level of granularity that you can use to filter in your workflow, the trigger of the workflow. So for example, for pull requests, you can filter to only fire your workflow when a pull request is assigned, edited, or a review is requested on a pull request. And another example, for issues, you can trigger an event when the issue is open, edited, or closed. There are many more different event types, and the list is actually quite rich. There are a large number of things you can do. It's really amazing. Now, let's take all of that and apply this to a Salesforce DX project to see a bit, to bring a bit more context with things that you're most likely familiar with. So I've taken the same color code here, and what we're looking at right now is a CI environment. So the CI environment that we have here is a workflow. When this workflow is configured to listen for push, so when code is being pushed to a branch, it fires the first job. The first job is something that you would need if you were running Lightning Web Components in your project. So it contains 5 different steps, and I'm going to list them out. The first thing it needs to do is to check out the source code. So remember that the job works on a Docker image, so it's a standalone thing, and it does not necessarily know about your source code. So you're going to run first a git command to check out your current source code. Of course, there are helpers for that, and this is nicely packaged in one of the provided actions. So that's the first step that you need to perform, and this is probably going to be true for all of your actions, checking out the source code. Then, since this is a Lightning Web Components project, we need to actually to install Node.js. Most of the tasks that you can perform on the development side of things for a Lightning Web Components project require Node. So we're going to install Node and several dependencies, and these are going to be dependencies we're going to be using in the 3 upcoming steps. The next step is to verify the code format. So that's something that we tend to do, for example, in the sample applications that are provided on Trailhead, and I'll get more in details on this configuration. What this does is actually aligns the format with a specific set of rules. So it's making sure that the formatting respects those rules. At any point, these different steps can throw in an error or basically return with a non-zero exit code, and this will actually fail the step, which will in turn fail the job and halt the workflow. So assuming the format is okay, the next step is to lint the JavaScript code with a tool called ESLint, which is pretty much of a standard for linting JavaScript file. It's something that is owned by the community. And final step is actually running your JavaScript tests, and we are using Jest for that to run Lightning Web Components test. So this can take a bit of time, but it doesn't really matter. All of that is isolated. Now, there's a rule that says that a job can last for up to half an hour, if I remember well, something like that. So you have a lot of time here, and this is probably something you can work with GitHub if you have a paid-for subscription. So that's the first job. Once the first job is completed, and only if the first job is complete, we'll move on to the second job, which is a bit larger. This second job I call Scratch Org Test. So it's going to do several things. It's going to make sure our Salesforce DX environment can be deployed, and we can do a couple of things with it. So remember that this is a different Docker image. It does not know about the previous job. It doesn't know about the previous context. All it knows is that it's being triggered after another job. So new job, this means that we're going to have to check out the source code, of course, but we also have to install the tooling to work with Salesforce project. So this means we need to install the Salesforce DX, Salesforce CLI or Salesforce DX. So this is basically done with a shell script. So we're running a shell script which will download an image of the Salesforce CLI installer and run it. Then we check out the source code. We authenticate with a developer hub. So because we're going to be using Scratch orgs to run our CI environment, we'll need to authenticate with a developer hub first. The developer hub lets us create Scratch orgs. And here we're using something that I haven't written on the slide here, but we're using secrets, sorry. And secrets basically are something that allow us to hide certain parameters from the configuration of our flow. With an action, you can pass in certain settings like the authentication URL for your dev hub. Let me just hide my head now from the next part because you probably want to see it. So let me just move to the screen only. There we go. So after you have authenticated with the dev hub, you're going to run a command from the CLI which lints your Aura code. So it's basically making sure that the syntax is okay, that you're using the right settings. Then you're going to create the Scratch org. So starting from there, it gets interesting because you're now connected to a Salesforce org. With that, we continue with the other steps that are still part of this flow. I had to return to the line just to put everything here. But what we're doing here is that we're now pushing our source code using the CLI commands. We're maybe assigning some permission set, importing some sample data, all of that with CLI commands. Then we run the Apex test commands. So this is probably what will take the longest in all the entire flow, but this is what is the most critical, that your Apex code works on the Scratch org. And then finally, the last step or last action here is to delete your Scratch org at the end of the flow. Now, this is something that you want to do always to make basically sure you tidy up after finishing your CI flow. So this particular last action is generally set up to always run. So that even if you had a crash in your Apex test, for example, or your Aura didn't lint, you would just jump to the last step and still execute the delete scratch work instructions. Another option, of course, is to simply set a scratch work with a very short lifetime, basically. All right, back to the slides here. Now, I suggest that we take a look now at some actual code. So we've seen actions. Sorry, we've seen actions from a theoretical point of view. Let's now take a look at some source code, see how this runs. So as an example today, I'm going to take a simple project here. I'm going to take one of the applications from the sample gallery, and I'm just going to take the first one called LWC recipes. This is available on GitHub, and all of what I'm going to show here today can be seen from this particular application. You can see here there's a little view on GitHub link here, which takes us to the GitHub repository of this particular project. Now, when you look at the project, if you scroll down, you'll see those little badges here. These are tied to a GitHub workflow. Right now, I have a little problem with my packaging flow here, so it's failing. But we're going to be looking at the Salesforce DX workflow, which is the one that runs the test and runs the linting and everything. So these badges are a dynamic link here, which reports the status of our flow. If I click on it, it will take me to the Actions interface. So this is something that you can also get from the top level tabs here from the repo Actions. Now there are multiple flows that are running in this particular project. It's a bit advanced, but the one we're going to be looking at is the Salesforce DX scratch workflow. So before I continue with the user interface here, I'm going to jump to the source code and we're going to see how this is configured. Let me just increase the font size a bit so that everyone can see. I'm just going to reduce that. So we're going to be looking at our .github/workflow folder. And there you can see I have a couple of YAML files. So let's start maybe with a very simple flow that we use here called branch naming. This is really a simple flow here. And this is something that runs all the time, except for the master branch. So the way it works is that you name your flow here. This is what will be reported in the user interface. You then have a block here which lets you specify on which event the flow runs. So this is happening each time there's a push on a branch. And then you have some sub-filters that you can apply for this particular type of action. In this particular example here, we're ignoring the master branch. So basically this workflow here will happen each time there's a push on any branch except for master. You can also have filters that work the other way around that only include specific branches. Now, after that, there are the list of jobs. This particular workflow only has one job here, which is validate branch name. And this particular job here is running on the Ubuntu Linux image. Simple. And then there's a set of steps here. Again, it's a very particular example. There's only one step in this one job. Now, this is a GitHub action. The action here is coming from a GitHub repository. And you can see here, this is the username, the name of the repository, and this is, after that, the version. So this is taking the latest version of the action branch name from this particular user. Here we can supply a name so that we have something that is reported in the user interface. And we can pass in some parameters to this particular action. So we've been looking at basically the README from this action and supplying the right values. So what we expect here is basically to have something. I need to explain you about the regex here, but we expect to have something with characters, then a slash, then another thing with character. This is because our branching naming convention is like, for example, my username slash the task I'm doing. So there's a minimum length and certain rules. This is just to keep things tidy because we have quite a few pull requests. This is really a simple example, but this is not yet tied to a specific Salesforce DX project. So maybe let's now take a look at a Salesforce DX project. So we're going to be looking at this particular product here called Scratch.org SFDX CI Master. This is something that runs each time there's a push on the master branch for the recipes workflow. So you'll find some similar patterns. What is interesting here is that there are quite a lot of steps on this one. This is pretty complex, and this is going to be something similar to the slide I showed you earlier with all the different steps. So let me just compress this a bit so that we can read it in an easier way. So the name of the workflow is just Salesforce DX Scratch.org, and this is what you saw in the badge that I showed you in the README. This is happening each time there's a push on the master branch. The other branches are not targeted by this specific flow, and you'll see that we have other flows like the pre-release flow, which are running on the pre-release branch. Now, this flow now has two jobs, formatting and linting, which also does Lightning Web Components test, by the way, and the Scratch.org tests. And so these are more or less what I've shown you earlier in the slide. So we're going to go over these things very quickly here, but first thing is we check out the source code. We then load some cache for Node.js installation. So this is just a shortcut basically to install Node.js project very quickly. With these two actions, we're just restoring the previous install that we had with a cache mechanism. I won't go into the details of that particular stuff. It's a bit too advanced for now, but if you're interested, you can look into that. It's a way to really quickly install Node.js to save some time. Now, there is the rest of the instructions, which is really more important for the flow. We are running prettier, and this is using a node command. So here in the run, this particular action is just a shell command. This is not a GitHub action in the sense that there is no repository tied to that particular action. It's just running a shell command. So this is very different from something like this here, which is actually a custom GitHub command, a GitHub action, sorry. So you see the use here means that we're calling an action from a repository, but when it's just run, this is just doing some shell script. So if you actually do these things on your own computer, you can run those things provided that you have Node.js installed and you're in the right project. So these are actually calling scripts that are defined on the project. And these are defined here in the package.js. So very quickly, there is a script section in your package.json file, which is the node installation, the node configuration file, which contains a list of different scripts. And doing npm run with the name of the script, like lint or test, will run those commands. So this is what we're doing basically with the commands that we're doing, like run, prettier, verify. So now we have verified our source code with prettier, the format is okay. We're doing some linting with ESLint. Same thing, shell script command that calls Node.js. So npm for Node.js, run, and then a Node.js script name. And finally, again, one last thing, we're running the unit test with jest, and we're also using the coverage argument here to run a test coverage for Lightning Web Components. All right. Now, if this first job works, fine. Let me just minimize that. If formatting and linting works, we'll be able to start the second job called Scratch.org test. And you see that this need line here means that this first job needs to validate before we run the next job. And again, remember, this is a whole different environment, so it's another image that is being spun up. There's no link to the previous job. It just needs to run after the other. The installation command that I mentioned earlier to install the Salesforce CLI. So this is just a shell command again, but combined with actually it's more than one shell command. It's a set of different shell commands that are chained together inside one step. Checking out the source code. And setting up the Salesforce DX Dev Hub authentication with a URL. Now, I want to bring your attention to this particular syntax here. This syntax with $ in double curly brackets allow us to read values from the secrets. And secrets is a user interface within GitHub, which lets us add configuration variables which are kept secret. So this is replaced by a URL which is uniquely allowing me to authenticate with my dev hub. So this is being injected in here and saved in a text file called devhub sfdx URL. And we're going to use that in the next command here to load that particular devhub URL and store it in our Salesforce DX environment. So with that, we're actually authenticated with the devhub, and we're saving it as devhub alias. Then a few more commands: linting our components, creating the scratch org, pushing the source code to the org, assigning the perm set, importing sample data, running the Apex test with code coverage, and finally, important, doing some housekeeping by deleting the scratch org. Note the if always means that this action will always, or step will always run even if one of the previous steps fails. That's important to make sure that we always clean up our mess after we've finished with the scratch org. That's a good practice. So that's how the flow works. There are many more examples that I can show you, and in particular, we're working with those GitHub Actions to do packaging as well. So when we're actually releasing a new version, there are other scripts that are running in here, like this one here, that actually do kind of the same thing we saw earlier, but run on master and are triggered when the first app folder changes. And for example, what is different with that one is that there's a packaging org which is being set up, and we're using other commands to actually create a new package version, and we're saving that package version later on in the README. So we're extracting it, making sure it propagates, and we're saving that in our DX configuration and pushing that to the README. But this is a bit too advanced. I'm not going to go more in details on that one. Do note that everything in here is public. So because the Lightning Web Components recipes application is public, you can actually find all of that when doing on the repository, going in .github workflows, and here you'll find the files that I've been looking at just in my VS Code environment. And if you want to follow one of these flows, you also have access to this action tab here again, which lets you see what happened in the execution. So the last commit we made here, well, was this one, and this was made by my colleague, and the flow ran on master. So let's check out what happened on this one. This was running the Salesforce DX scratch org workflow. That's the one we saw, and you can see here the two jobs. When you're clicking on the job here, you can see the list of different actions. And if you want to see more details, they will be checked as they go, but you can also expand them to see the output of the different commands. Now, most of the time when the commands or actions, are successful, they don't output anything. And finally, the second job that was run, same thing. You can see all the steps that are being reported as passed, even up to the point where we delete the scratch org or where we run the Apex test. This can be more interesting. So this is exactly what you would have in your terminal if you are running those things, except GitHub Actions lets you automate all of that. So that's very convenient. So that's it for the overview of GitHub Action. Let me get back to the slides now. Okay, so we saw that. As a summary, we saw that GitHub Actions allow you to automate quite a lot of tasks. The examples I show you are very specific to CI, but you can do more than that. For example, you can automate the processing of issues. For example, if you want to triage issues automatically, this is something that can help you. You can, for example, automatically assign labels to issues, whether they are questions or bugs, for example. And you can also do some things like sending you messages, because you can trigger whatever custom code you want from a GitHub event. There's really no limit to what you can do. Second point, GitHub Actions are very code driven. So all of that configuration happens in that YAML file we saw earlier. There are a few things that you can do, of course, with secrets that lets you add configuration, but almost everything is done without clicks. And that is very convenient because, for example, if we take the way we've configured our sample apps, what we've been mostly doing is aligning our CI workflow environments by just copying and pasting this workflow directory over to the next apps, and then fine-tuning a couple of those steps. But that's super powerful because you can start a project by just copying an existing CI configuration and it will work in the context of that project. Finally, I think you saw it, this is very extensible. I haven't even scratched the surface on the list of events that you can use, but there are already tons of those, and you have access to the entire GitHub API in the APIs in the context of those actions. So you can really create your own actions, you can share them with the marketplace, or even keep them for yourself if you want to link to your own repositories. So I really suggest that you give them a try. Take some time to look at the source code from the sample apps, inspect it and understand a bit how it works. It's really powerful. We've tried different CI solutions before, and I find GitHub Actions is really the simplest and the most convenient because there's almost no setup required. So that's very interesting. And there's a very large community, also lots of different actions that are available from this marketplace. That being said, if you're interested in learning more about the different events or different configuration options for those actions, check out the documentation site from GitHub Actions. It's very complete, lots of examples, and they're also quite a large community trying both things out, so it's quite easy. Also, if you want to read a bit more in the context of Salesforce, my colleague René Winkelmeyer recently published, I think it was in January, published a blog post on GitHub Actions. So if you go on the website for the blogs, you can find this action blog by searching. Finally, again, reminder that all the actions and workflows are configured and are publicly visible in the sample app, so make sure you check those out. Trellit.salesforce/sample gallery. That's it for me. I'd like to thank you for joining, and I hope you had a great time and you learned new stuff. Do give it a try, and see you next time. Thanks again. Bye.